it means during last 50 years, which is our default return period. So if that bridge was existing for 50 years and in 50 years we have got no history of any adverse incident like water overflowing or some washout or excessive cover, then your waterway of existing bridge may be retained. You don't have to do design discharge calculation. You don't have to do waterway calculations for that bridge. Retain the existing waterway, merge both, join both of them. After taking measures for safety as considered necessary by chief engineer in charge, because construction does this work. So chief, what are these measures? Basically joining both the waterway, then approach, pitching and all you do in bridge, river training and protection work is must. Those sort of normal protection work you do and you retain the existing waterway. First case, simple. Second case is locations which have history of past incident. There already some problem has happened in return period. There you have to do the calculations de novo. Their waterway has to be reassessed based on the freshly estimated design discharge. So you calculate design discharge for your return period, then reassess the waterway and give that much waterway where there is a problem. Third situation you may have where the history or the bridge itself is less than 50 years old, but there is no past history of overflow, washout or excessive stuff. But your data available or the bridge itself is less than 50 years old. So there what you do, there you have to take a judicious decision on case to case basis. First you calculate, let us see and see how much extra is coming. If reduction, if your existing is too far less than your proposed, maybe you may have to rebuild the bridge. If it is only little bit extra, then you may decide कि ठीक है existing bridge retain कर लेते हैं. You will give some extra training or protection measures like that. So in those cases, you have to decide the waterway judiciously after calculating the design discharge and keeping in view the waterway of existing bridge on adjacent location. How far they are, how we will give transition in between that waterway if you give extra waterway, or can we give less waterway and its implications we examine. When we reduce waterway, water level may go up, your clearances may get affected. So we will see clearances after this. You may calculate revised clearance and you have to see, take a judicious decision based on site to site condition. So these can be three things. One, there is no problem. Second thing, there is a problem. Third thing, there is no reported problem, but your data available is less than the recurrence period. And logical, what should we do? Okay, clear? This concept should be clear to you. You need not remember figures and all, but you must know why something is done and how it is done. So this is simple concept that let us say you are doing rebuilding of some bridge. Your existing bridge is being rebuilt, including its foundations and substructure and all. That is dealt in para 4.5.8 of substructure code. There it says waterways shall be determined keeping in view the design discharge from clause 4.3 means like a new bridge. You have to do, because you are in any case you are rebuilding the bridge, you can do some extra work also, same logic. So you will redesign your waterway and other clearances also. You will calculate Q50 and then calculate the waterway. Now for strengthening the bridge, existing bridge is there, you are not rebuilding, you are doing some strengthening. And most strengthening, we are talking in terms of substructure basically. Most common strengthening which is done is jacketing. It is done in arch bridge and other bridges also. Let us say this is your superstructure and this is your substructure. Maybe this is abutment, these are piers, then abutment, or maybe this is arch bridge like this. So what you do is jacketing. Jacketing is, I think, has been covered separately. You must be knowing what precautions you must take and all. But what happens is, or here you do jacketing. You provide dowels and then do concreting here. And bottom also up to foundation, your jacketing should go, all those things. Here what will happen? Your waterway will reduce. In every jacketing, you will reduce the waterway. So it talks about what is to be done there. So it says for strengthening by jacketing, etc., reduction in waterway can be allowed by the CB, number one, if there is no history of overflow, washout, excessive cover, etc. That is number one. It must be checked from the record. Your record, what record can be there? Can anybody tell ये record कहाँ से मिलेगा? Which record will contain these details? That किसी bridge पे ये overflow, washout या excessive cover हुआ है क्या? Which record will we check?
So bridge register.
Yes, one is bridge register, another is section register. One is bridge register, but bridge register normally register will last for 5 to 10 years. Now, of course, it is online, so it will, but hard copies, if you check old, they will be maximum 10 years, otherwise 5 years. So if you want to check 50 years, either last 10 bridge registers, many times they are available. Some of the divisions have got very good practice of preserving them. Otherwise, check the section register. Section register will always have history of all this untoward incidents. So, and then you take measures as necessary for felt by field engineer and CB. As necessary at site, normal your bridge protection work, pitching or whatever, launching apron, normal things. So it says, of course, CBE can allow this reduction, but you must do detailed calculation of waterway, and based on that you must do the calculation of clearances. You will see clearance when we go further. Due to reduction in waterway, your clearances will reduce because your water level will go up. There will be a flux. So afflux calculation we will see just after this. Then you must do detailed calculation of waterway and clearances. And clearances you must get whatever is required. So here we are taking a risk. Okay, all right. Even if waterway increases, no problem. My clearance, as long as it is available, I will allow. CBE can allow that reduction in waterway for strengthening. Okay, and where the required clearances are not available, then you must do rebuilding the bridge. There you cannot do jacketing and strengthening with systems like jacketing. Clearance, there is no margin given in the reduction in clearance. Some margin is given reduction, we will see. Below that, it cannot be there. So now we have seen waterway for new bridge, for rebuilding, for strengthening, for new line or existing line gauge conversion. All situations have been covered, right? ठीक है यहाँ तक?
Yes, yes.
Okay.
Yes, sir.
Now we go to scour depth. Now we have decided the horizontal dimension of the bridge. Now vertically scour depth, and based on scour depth where we should rest our foundation. Open foundation hai, well hai, pile hai. Where should we rest it? So number one, for scour depth calculation, there is a discharge which is known as design discharge for foundation. It is called QF. It is given in para 4.4. First was Q, or maybe Q50 or Q100. This will be called Q50F or QF, whatever you call it. You will calculate that value. Basically, you increase the discharge for foundation because, as we know, in any structure, repairing or strengthening or retrofitting foundation is most difficult part, and therefore you want to take extra measure of safety in case of foundation. You increase the design discharge, and this discharge is not increased for checking freeboard. We will see freeboard. You will use the increased discharge for scour, you will use the increased discharge for clearance, but for checking freeboard, you will not use this discharge. You will use only Q50. Now, how this increase is done? It is done based on catchment area. If your catchment area is up to 500 kilometers square, you increase it by 30%. From 500 to 5000, your increase is from 30 to 20%. In between, you can do linear interpolation. 5000 to 25,000, this is 20% to 10%, and above 25,000 square kilometer, less than 10%. So what you see here, as your catchment area is increasing, the extra margin of safety which you are providing, or the margin by which you are increasing the design discharge, is decreasing. What is the logic for this? Anybody? ऐसा क्यों है? जब कैचमेंट एरिया बड़ा हो रहा है तो डिजाइन डिस्चार्ज को इंक्रीज कम क्यों कर रहे हैं?
सर बिकॉज रिमोटेस्ट पार्ट से तो टाइम लगेगा, फिर वो एक शॉक जो है सर वो एब्जॉर्ब हो जाएगा, शॉक कट नहीं आएगी सर।
बट वो टाइम तो हाइड्रोग्राफ में कैप्चर हो जाएगा जब Q50 कैलकुलेट करेंगे। आप जो कह रहे हैं बेस इन लैग टाइम या टाइम ऑफ कंसंट्रेशन, वो तो उसमें कैप्चर हो जाना चाहिए। There is one more reason. There is one very strong reason.
I think for larger catchments,
the difference in maximum rainfall and average rainfall will keep on reducing. I mean, the estimate which we are making a guess for maximum rainfall, whatever formulas we are using.
And thoda sa you are near to actually larger is your catchment area, more accurate is your prediction of design discharge. आप देखिए small catchment के लिए you use RBF 16, which is a very approximate report, some few formula and you do it. When you go to medium size catchment area, you go to flood estimation report, which is more accurate than your rational formula or RBF 16 approach, but not again very accurate. Some synthetic unit hydrograph and all we manufacture and all. When your catchment area becomes furthermore, you do actual observations, and bigger is your catchment area, more and more accurate method of predicting Q50 are adopted. So the uncertainty involved, the element of standard deviation involved in case of design discharge calculations are lesser as you go from smaller catchment site to bigger catchment area, and that is the reason you decrease your extra margin of safety. ठीक है? Okay.
Yes, sir.
This is first step, QF calculate करेंगे. अब scour पे आते हैं कि depth of scour कैसे calculate करेंगे. This is again given in para 4.6 of substructure code. अब ये क्या कहता है? This again depends on, as I told you, like your width of waterway depends on type of your bed. So first, for alluvial or sandy or silty, now you see here, these are those beds where Lacey's regime width calculations apply, or Lacey's formula applies, if not regime width, Lacey's formula can apply. Originally it was for alluvium, but as I told you, for sandy and silty channels also it has been validated, and there can be two cases. First case is covered in para 4.6.3, where for natural channels in alluvial beds or silty and sandy, where the width of waterway provided is not less than Lacey's regime width. हमने Lacey regime width PW calculate किया था, C under root Q some 4.11 or something. उससे ज्यादा width यदि हमने provide किया है, actual width. Normally we say कभी हम कम करते हैं, कभी ज्यादा, depends on situation. So if you have provided more than whatever was required as per Lacey regime width, based on all considerations, RSI, economy, navigation, सब consideration के base पे, and your bed is of this type, then you use this formula. D is cover depth, 0.473 QF by F. And second case, where width of waterway provided is less than regime width, here it was more, here it is less, or where waterway is narrow and deep and has sandy bed, etc., then we use this formula for scour depth calculation. 1.338 rather than capital QF, it is small QF square. Here it was only QF, here square divided F to the power 1 by 3. D is cover depth in meter. Again, these equations may not be dimension neutral, so you must be careful about their units. D is cover depth in meter. Small QF is discharge intensity. So Qmax or meter cube per second per meter width, whatever is your width there. QF is foundation design discharge in Qmax, and F is silt factor for material in scour zone. How silt factor is arrived at, we will see in the next slide. So for this type of river beds, alluvial, silty or sandy, we must calculate by using appropriate formula for Lacey's scour depth. Then coming to silt factor, this is given in para 4.6.5 of substructure code, that silt factor shall be determined for representative sample of bed material. You take bed material, a representative sample, do the sieve analysis, find out its particle size, and from there you calculate F. F is given by this formula, 1.76 time under root M, and M is weighted mean diameter of the bed particles. Whatever particles you do sieve analysis, whatever is percentage, take the weighted average, that will give you the weighted mean diameter, and you can take it 1.76 multiplied by under root M. And our code gives this table. Here it is coarse silt, fine sand, medium sand, coarse sand. So silt and sand, because silt, sand and alluvial also will fall in one of this category. So either like coarse silt, your normally weighted mean die of particle is this, and your value of F from this formula will come this. Fine sand, it has divided into two categories where value is 0.08 mm particle size or 0.15, and these are the corresponding F values. Similarly, medium sand has been divided into two categories. These are the M value, these are the F values, and coarse sand into three categories according. So either you can use this table and whatever size is fitting in, or you can calculate actual M, and then using this formula you can find out the silt factor. So then, and using this silt factor, you use Lacy's cover depth formula and you determine the cover depth. Then in addition to that, para 4.6.6 also says whatever cover depth you are obtaining, this depth should be increased to obtain maximum depth of cover for design of foundation, protection works and training works. The depth of cover which you use for foundations and your training and protection works, that you should increase further depending on this. If your river is straight, again you give some extra margin basically. If your river is straight, there will not be much of turbulence and things which cause more cover. So you multiply this by 1.25 means 25% increase. If there is some moderate bend normally may happen in long apron in training and protection work here, or guide bend, etc. Then you increase it by 50%. If it is a severe bend, again it happens in training and protection work like some places. If it is severe bend, then you apply 1.75D. At right angle bend or at nose of the pier, like if you have got a pier here, it will hit at 90 degrees. Sometime your bend also is 90 degree, your water comes and hits here. At those locations you multiply it by 2 means 100% increase. And if there are severe swirls, that is against mole head of a guidement, there it almost reverses. If you see the mole head, there you use factor 2.5 to 2.75D. These are various factors. For foundations, for pier you use factor of 2, and for abutments you use factor 1.5D. Yes. Yes.
The maximum limit on the depth of the cover.
Pardon?
Is the depth is according to the physics of the flow, or sir, is this the maximum depth of cover is according to the physics of the flow, or according to the lifespan that we have?
No.
Over this lifespan, this depth we can allow.
Maximum depth does not depend on lifespan. Lifespan indirectly will get captured in your design discharge. Your lifespan will get captured in design discharge, and since design discharge is a parameter in cover depth, so it gets accounted there. Here it is how much swirl or eddy currents are generated. It is based on this. This factor is basically taking into account, let us say your water is flowing smoothly, then there will be very less chances of eddy currents or scour. Whereas if my river is like this, then obviously in this edges and here there will be eddy currents or squirrels. Or if my river is like this and there is a pier in between, it will go and hit the pier, and around this pier there will be eddy currents and there will be swirls which will cause more scour. So the factor here is to take into account the factors which cause eddy currents or formation of swirls which increases the scour.
So sir, the depth of this cover will depend upon the eddy current.
Not only on eddy current, depth. First you have calculated based on other condition. This is increase in depth due to eddy currents. This is, you are increasing the D. D is calculated based on so many considerations. You have already seen that. You are increasing D because of this effect. Yes. That is what this para is about. Okay. Clear? Right. Then that was this increase we have to do for all cases. That was calculation method first when Lacy's scour depth was applicable. Now for fleshy rivers, like where you will have boulders and gravels as bed material, Lacy's formula will not apply. So there what should we do? Then para 4.6.2 of substructure code, it says wherever feasible, soundings shall be taken in vicinity of the site, preferably during or immediately after flood. So wherever you have this sort of rivers where they say formula or other formulas don't apply, For rivers with boulders and gravels, bigger material as bed material, no formula will apply in fact. So in those cases, what you must do is we must take actual observations and sounding. What we do, sounding, and sounding should be done as close to the maximum discharge time, which is immediately after flooding, as close to that possible. Now, whatever sounding you have taken, over that also you have to apply some factors. And what are those factors? You have to allow some factor. Allowance shall be made in observed cover depth. First is, when you are taking sounding, let us say this year you are taking sounding, even though you might have taken in peak flow this year, but that may not be the design discharge. It may occur once in 50 years. So the difference between discharge when you have taken the sounding and difference in design discharge. So the design discharge being greater than this, some allowance due to this factor. Now, how much allowance and all, it again depends on what is the slope, what is the type of material, what is its siding, either based on experience, there is some literature, or do hydraulic modeling. You have to do hydraulic modeling after taking field observations. Then there will be increased velocity due to constriction. Today, you are taking cover depth here when river is obstruction free. When your bridge gets constructed, there will be effect of obstruction for that which you are applying previously 0.25 and all. So here also that effect also you have to apply some allowance, and then increase in scour in proximity of pier and abutments. In addition to constriction in waterway, pier and abutments, they present a physical hindrance also in flow of water. So taking into account all these effects, you will apply over the observed scour, and that will be your maximum scour depth. So this is how it is to be done for such rivers. So now river can have, if it is hard bed, there will be hardly any scour. If it is, let us say, rocky bed, there will be hardly any scour. You can take some nominal square and do with that. If it is sandy, silty, alluvium, the Lacy's formula. If they are fleshy river, which normally have boulders and gravels as bed material, actual observation. And at the last, you may have clay beds. This happens many times. For clay bed also, our code 4.6.7 says wherever possible, maximum depth of square shall be assessed from actual observations, and then whatever allowance you have to add, you must add that. Now, many times people, of course, you are new, you may not be aware about, but many times when they take these classes for people who are working in the field, and especially people who are dealing or who have dealt with this design, they say ki sab IRC 76 mein, IRC 76 is our parallel code of IRC for road bridges. In that, I think part 6 or something is for substructures, or part 4, I am not remembering exactly now. There, they say कि वहाँ तो clay के लिए भी एक formula दिया हुआ है. Ultimately, river तो river है. Whether it is for bridges, for railway or highway, how does it make difference? And why don't we make use of that? It is probably reading between the lines. If you read that para in IRC code also, it says in clay soil beds, it is very difficult to find out of the formula, and therefore we must take actual observation, blah, blah, blah. However, considering some approximate something and for not very important with so many ifs and buts, this some formula is there which can be used. So IRC code also says in effect that preferably you must use actual observation. So our case also, if your bridge is important or major, use actual observations. Bridge is small, not very important, and then you may use that formula of IRC 76 or whatever for clay bed. Okay. ठीक है, ये समझ में आ गया स्कवर डेप्थ कैसे कैलकुलेट करेंगे?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
whatever we have seen in scour, let us see this sketch, it will make it clear. This is your water level corresponding to QF, not Q discharge, corresponding to QF, because for scour depth calculation you use QF. Now, from this, and this is your bed level, this is your river bed level. Now, first you will calculate value of D, maybe by Lacy's formula or by actual observation or whatever you method, and this will be your scoured level. This D, as I told you in first day itself, in this formula, this D is measured from this. Actual observation will be with respect to bed level, then you have to add the depth and all. So D, whatever method is applicable, you calculate, you will reach this level. This is your scour level based on calculated scour. Then you add some margin, as I told you, depending because of development of eddies or water not being smooth or because of development of swirls. So like in Lacey's calculation, you multiply it by 1.5 or 2 depending on whether it is abutment or pier. For other things, you add that margins for those 3 factors, and after adding that, you will reach this level, which is called maximum anticipated cover level. So this was calculated. This is maximum anticipated cover level. This term comes many times in design of bridge and many other places. Below that, you have to give some length, which we call grip length. Sometimes grip length is used more in case of deep foundation, but open foundation also you to give some length. We'll see just after this. And this will be your founding level. This will be your foundation level. So your depth of foundation will be this, because this is bed level. So this is how you decide your founding level for the foundation. Okay.
Yes, sir.
Okay. Now only thing is grip length. So the so-called grip length, what it is? Depth below maximum cover length, which we have called grip length. So this is also given in substructure code, this para 6.1. Roman 4. For open foundation, it says the depth of foundation shall not be less than 1.75 meter below the anticipated cover level. Maximum anticipated is actually. So grip length or so-called grip length will be 1.75. So your bottom of foundation will be 1.75 meter below your maximum anticipated cover level. And for other foundations, it is covered in para 6.9.1 of substructure code. Deep foundation, it says depth of foundation below the water level shall not be less than 1.33 times of maximum depth of cover. So what does it mean? Whatever your maximum depth of cover you had calculated, this maximum depth of cover, it's 30%, 0.3 of this. Or 33%, 1/3, 1.33. This is what it see, or just 1 minute. Let us read it. It says that is what depth of foundation below the water level. See what is below the water level. So cover will be D and grip length will be 0.33. Okay, this is for deep foundation 1. Yes.
सर जो अभी हमने थोड़ी देर पहले फैक्टर्स देखे थे, लाइक सीवियर बैंड है, ग्रेजुअल बैंड है, 90 डिग्री पे है, तो वहाँ पे सर हम स्कावर डेप्थ को थोड़ा सर वो इंक्रीज कर रहे थे, तो वो सर उस इंक्रीज के बाद जो स्कावर डेप्थ हुई उसको अकाउंट फॉर करके 1.33 लगाना है या फिर उसके पहले
अकाउंट फॉर करके, उसको अकाउंट फॉर करके फिर उसका 1/3 और नीचे ले जाएंगे आप।
ओके सर, ओके,
क्योंकि वहां तक तो स्कवर हो ही जाएगा ना। बेसिकली पर्पज ये है आपका ग्रिप लेंथ का कि जब आपका स्कवर हो जाए तो फाउंडेशन शुड स्टिल बी स्टैंडिंग, उसका स्किन फ्रिक्शन या जो भी मोबिलाइज होते रहना चाहिए। तो यहाँ तक तो हम मानते हैं कि स्कवर हो सकता है वर्स्ट केस में, तो उसके नीचे ले जाएंगे हमेशा।
ओके सर।
नाउ अनदर थिंग इज, हमने ये कैलकुलेट किया, ये तो कैलकुलेटेड वैल्यूज है ना, डिपेंडिंग ऑन वट एवर इज योर मटेरियल इन दिस एरिया। इस एरिया में जो मटेरियल है और यहाँ तक उससे एफ निकालेंगे वो सब। ग्रिप लेंथ वी हैव टू प्रोवाइड बिलो दैट, बट लेट अस से यहाँ रोक आ गया, यू गेट ए हार्ड स्ट्रेटा और रोक हेयर, देन यू शुड नॉट गो बिलो रोक। आप यहाँ रोक दीजिए, यू स्टॉप इट हेयर एंड वट एवर रोक में बेंचिंग वगैरह करना है वो कर दीजिए। देन इफ योर हार्ड स्ट्रेटा इज मेट एनीवेयर in between, जिस डेप्थ तक आप जा रहे हैं, then you need not excavate up to here or chisel it up to here and then put your foundation. If you meet hard, because hard strata में तो cover होगा नहीं, तो आपको बीच में जहां भी hard strata आ जाता है इस डेप्थ में, then you should stop at that hard strata. It says in case of inerodible strata, and please remember inerodible strata is rock. Clay is not considered inerodible strata. Many times people say कि clay erode नहीं होता है normally, but it is very clear clay is not considered inerodible. It may be less erodible or very less. Inerodible means rock. In that case, if it occurs at higher level than whatever depth we are going, the structure may be founded. Your founding level can be at the rock level, wherever you get the rock in between. So this is about depth of foundation, where we have to found our foundations. ठीक है? This is also clear?
Yes, sir.
Yes, sir.
Yes, sir.
Some question? Somebody was asking some question.
Yes, sir.
Yeah, please tell. No? Or it was some sound in background I heard. Right. No question. Right. Then we'll go to next another small. Now we come to vertical clearances. The freeboard and C vertical clearance for superstructure. For that, first we need to find out the afflux. And afflux calculation is given in para 4.7 of substructure code. Para 4.7 says for streams with non-erodible bed. Now what is the significance of this? Now let us say this is my bridge. This is my river. This is bed. Water is flowing like this. And when I construct an obstruction here, pier or whatever, what happens? Some energy generated here because of this obstruction. There are eddies and all. Now, because of that, two things can happen. If my bed is soft or erodible, maybe scour will be here. That is one thing. So some energy is dissipated in creating the scour, and some energy creates your afflux here. And so there is always a balance between scour and afflux, H and D. If your bed is soft, scour will be more, and if bed is very, very soft, scour will be maximum, afflux will be 0. But if your bed is harder, scour will be less, afflux will be more. So whenever we talk about afflux, this is maximum afflux which will happen in non-erodible bed. When I assume my bed is, let us say, highly non-rock, something like the very hard, in that case I will have maximum afflux. So we must always be clear about this. There is always a trade-off between afflux and scour. Both of them we can take maximum only for design if it is not much, but if some places you got doubt, then you can reduce the afflux also depending on how much scour you are taking. So that's why word used for streams with non-erodible beds, it means maximum afflux. The afflux is calculated by using a formula which is called Molesworth formula. This is how this formula looks like. H equal to V square divided by 17.88 plus 0.01524 multiplied by A whole square minus 1. H is afflux in meters. V is velocity in unobstructed stream, means where your area has not been reduced due to some. So there V, and capital A is unobstructed sectional area of river in square meter, and small a is obstruction. So with obstruction, what is the net area? Without obstruction, what is the gross area? We already do this calculation for finding submerged V in depth of piers. From there we can use it, and we can calculate afflux by using Molesworth formula. And then I told you, this is logical. It says in para 4.7.2 that in case of rivers with erodible beds, full afflux as calculated by formula may not occur. Some energy will go in scour, so you can, if you want, you can reduce the afflux there suitably. Now come to clearance. How much minimum clearance is required? And that is given in para 4.8. So once you have calculated afflux, now your whatever was water level, you added afflux to that. That will be your calculated HFL. Am I right? Your maximum water level corresponding to design discharge or whatever discharge, foundation discharge, if it is clearance. Add afflux in that. That will be your calculated HFL, CHFL. And another will be observed HFL, which you can check from the site records. Whichever is high will be your actual HFL. Taken? Clear?
Yes,
HFL
sir.
And once you have HFL, now clearance is up. अप्रोच बैंक का क्या लेवल है, आपका फाउंडेशन का बॉटम है, आपका सुपर स्ट्रक्चर का बॉटम का क्या लेवल है, देन फ्री बोर्ड एंड क्लियरेंस दे कम देयर. सो क्लियरेंस आर क्लियर कवर्ड इन पैरा 4.8. रिक्वायरमेंट ऑफ क्लियरेंस 4.81.1 says the minimum clearances for bridges, and this excludes, why it excludes I will tell you. It excludes arch bridge, it excludes siphon, it excludes pipe culvert, and it excludes box culvert. Excluding this arch, siphon, pipe culvert and box culvert, minimum clearance required is this. It depends on discharge. This is foundation discharge, QF, because we are calculating clearance. Free board में normal वाला discharge होगा, design discharge. For as the discharge increases, for 0 to 30 it is 600, 31 to 300, pro rata between 600 to 1200, 301 to 3000 1500, and above 3000 1800 or 1.8 meter. These are the clearances required. Now come to this. In 4 में क्या होगा? Arch, siphon, pipe culvert and box culvert. this is given in para 312.3 of IRBM, excluding arch, means siphon, pipe and box. The siphons, the pipe and box culverts, they are designed as pressure conduits. While designing them, you also take the hydrostatic pressure into account, and therefore for them it says no clearances are required. You can take the clearance as 0 for these siphon, pipe and box, right? Ab arch mein kya hoga? Somebody has asked this question that day also when we were discussing clearance very first day. This is how in arch there is a different method and different methodology which is given in para 4.8.2, and it says minimum clearance is like this. It depends on span of the arch. So in arch, this is your springing level, this is your crown, and this is considered rise. This is called rise of the arch. So for arch of span less than 4 meter, the clearance required is rise of the arch or 1200 mm, whichever is more. For span between 4 to 7 meter, it is 2/3 of rise or 1500 mm, whichever is more. For 7.1 to 20 meter, it is 2/3 of rise or 1800 mm, whichever is more. And above 20 meter span, this is the span of the arch, it is 2/3 of the rise. So in arches, this is how it is measured and done. So this is about minimum clearances requirement again for new bridge. Now let us come for other cases. When you are rebuilding existing bridge or building new bridge on existing or new line. Number one, you are rebuilding the bridge, so you are doing everything new, or you are building the bridge on an existing line. Means your existing line is there, your extra openings sometimes you provide when there is a repeated complaints of floods and all, or you are making a new line, entirely new line. Then it says these clearances can be relaxed by PC or CB in case where adoption of these clearances will result in heavy expenditure or serious difficulty. Sometime, let me give you an example. Let us say this is your two lines and here there is an yard. Something like this. In yard there are a lot of things, platforms and so many things. Gauging level there is very difficult, and you have got some bridge just at the near to yard. And here, if you want to increase the clearance, if you are not getting, you have to raise the rail level. The moment you raise the rail level, all your gradient and all, they will start getting infringing for the requirement for yard, and removing that will require very heavy expenditure. Or I will tell you another example where one case we had actually done. There is a bridge 85 in Howrah Kharagpur section near Panchkuda. In that bridge there are 3 lines in this side. After that there are 2 lines. This is Panchkuda station. Just after Panchkuda this bridge is there. And if you see its vertical profile, the gradient is 1 in 150 and 1 in 150, which is ruling. Somebody's mic is on, please switch it off. This is the ruling gradient. Now at this bridge, if you want to increase the clearance, your bridge rail level will go up. If you try to do this, it will infringe your ruling gradient. And if you have to follow 1 in 150, you have to go kilometers and regrading, and in between some other bridge station will come. So such situations, that is what it says, in locations where adoption of prescribed clearances may result in heavy expenditure or serious difficulties in execution, then some relaxation is allowed. That relaxation depends on discharge. If discharge is less than 3 cubic Qmax, you can adopt 300 mm rather than 600 mm minimum given there. For 3 to 30, you can adopt between 300 to 400 on pro rata basis, and 31 to 300 you can adopt between 400 to 1200 on pro rata. Above 300, this relaxation is not available. So this is the relaxation in case of either you are rebuilding the existing bridge, or you are building a new bridge on existing line, or you are constructing a new line, and where providing these clearances will need very heavy expenditure. So you can relax it. And while executing works other than rebuilding, what can be those works? Maybe you are changing the bed block or those sort of things, then you can retain the existing clearance. Means you should not lower the bottom of your superstructure. That's all. You should not reduce them. You need not calculate and check them whether 1200, 1500, 1800 मिलता है नहीं मिलता. Mostly because previously these clearances were very less. Over a period of time they are increasing. So existing bridge में आपको नहीं मिलेगा mostly में, but they don't. Another thing, where a tendency has been observed for the bed level of stream to rise. Some places, because of their topography at that area or because of some other region, bed level at that bridge has got a tendency to rise. Means there is a tendency of siltation at that location. Maybe वहाँ river का gradient change हो रहा है, या वहाँ constriction से तो बढ़ता है, constriction मान लीजिए wide हो रहा है river का bed वहाँ. All those locations, if the tendency is there, then you must take that into account. Change in bed level must be factored into those locations if you have observed such thing. So these are about clearances. What is the minimum clearance and what are the relaxation available? Clear?
Yes, sir.
Yes,
Right.
sir.
Last, we will see freeboard before we go for T, and then we'll finish this subject. Freeboard is covered in para 4.9 of substructure code, and for freeboard you don't use QF, you use Q. You don't use foundation discharge, you use design discharge. And freeboard requirement is given in para 4.9.1. It is minimum 1 meter. Minimum 1 meter freeboard is required, and you can increase it suitably if your heavy wave action or choppy waves are. Some rivers or some waterway have got this waves, heavy waves are there, whatever is wave height and all, if you feel, you can increase it suitably about, otherwise 1 meter. Now here also, freeboard also some relaxation is available where adoption of prescribed values would result in heavy expenditure or serious difficulty. Again, for freeboard also, you have to increase the freeboard. What you have to do? You have to increase the level of your approach bank. The moment you increase the level, rail level will increase. So as I told you previously, there may be some cases where it may be difficult. There, this is the relaxation. Rather than 1 meter, you can provide these values depending on your discharge, which is being catered. So for discharge less than 3, 600 mm rather than 1 meter. For 3 to 30, you can adopt 750, and more than 30, no relaxation is permitted. You have to provide 1 meter. So these are the relaxation in freeboard. And for works other than rebuilding, let us say you are changing bed block or something, or extending for doubling. Let us say you are doing doubling where existing bridge is there. Even if you provide freeboard in this bridge, other bridge will get breached away. So if you cannot get required freeboard, don't worry. The existing freeboard can be retained after taking measures for safety as per site condition, whatever pitching, other bed protection and all, as per site condition you take, but you retain the freeboard of the existing line. So with that, now after T, I will just 5 minutes, I will show you how these things have been captured, or maybe 10 minutes in a spreadsheet calculation. That also I have copied in your course content as well. It is available on Edison website, and then we'll go to our bridge foundations. So any questions on this before we go for T?